Hi friends, welcome to the problem solving session. In this class we see the transform based questions asked in TRB exam, right? So the first question is the region of convergence of the Z transform of a unit step function. So what they ask is ROC of Z transform of unit step function. So we know that Z transform of unit step function is this we must remember always. We cannot do it in exam. We must remember. What is that? Z by Z minus 1 with mod Z greater than 1 is ROC. Right? So, what is the answer? The option is option A. Mod Z must be greater than 1. Right? How can we get this? We know what is the what is the Z transform of a n u of n. This is a general formula we remember, right? A n u of n is z by z minus a, where mod z is greater than a. Instead of here a is 1. This is nothing but 1 power n. So wherever you find a, you put, so ROC is greater than 1. So option A is the right answer. Next, what is the question? The transfer function of a system is given by h of z is equal to z into 3z minus 2 divided by z square minus z by minus 1 by 4. The system is. So what they gave is transfer function. They asked whether the given system is what do you call causal, stable or minimum phase or none. So this is a very good question. Let us see that. Right. So they gave h of z. Z into 3z minus 2 divided by z squared minus z minus 1 by 4. We have to check whether this is causal, stable or minimum phase. So first we must know what is causal and stable system. A system is known as causal and stable if all poles lie inside unit circle. Then they give minimum phase. Minimum phase system. Minimum phase system is one in which all poles and zeros must lie inside unit circle. Here only poles. Here poles and zeros must lie inside unit circle. Okay, we find what is the poles and zeros of the given transfer function. So zeros first we find. How can we find zeros? Zeros are obtained by making zeros are the values which are obtained by from the numerator. The value of z which makes total transfer function 0 is known as zeros. So when you substitute here, you see numerator. In the numerator, if we substitute z is equal to 0, total transfer function will become 0. So 1 0 lies at z1 is equal to 0. Right? If you substitute z is equal to 2 by 3 here, what will happen? Total transfer function will be 0. So what is another 0? Another 0 is 2 by 3. We found 0. Now what we have to find is poles. Poles are obtained from the denominator. The value of z which makes total function is infinity is known as poles, which are obtained from denominator. What is denominator? Z squared minus z minus 1 by 4. First we factorize it and from that we find poles. So in order to find poles, the given polynomial is z squared minus z minus 1 by 2. So what about the poles p1? Let us find this is the root is a pole, right? So the roots are poles of the poles are roots of the denominator. So we find the roots. How can we find minus b? So minus of minus 1 plus or minus b squared minus 1 squared minus 4 into a into minus 1 by 2 or 1 by 4. It is minus 1 by 4, right? So 1 by 4 minus this means plus or minus 1, this is 4, 1 plus 1 root 2 by 2 by 2a by 2. So it is 1 plus 1.1414. So we have two poles. 1 plus 1.414, 2.414 divided by 2, 1.212. 1 minus 1.414, that is 0.414, that is minus 0.212. Right? These are all the 2 poles. If the system is causal and stable, all the poles must lie inside the unit circle. Let us see. This is unit circle. Right? So what about the radius? Unit circle is a circle with radius 1. Where is the pole? One pole at 1.212. It is 1.212, maybe here. It is P1. Another pole at minus 0.212, maybe here. So for causal and stable, all poles should lie inside the unit circle. But here one pole is outside the unit circle. So it is not causal and stable. Not causal, not stable. What about minimum phase system? For minimum phase system, all the poles and zeros must lie inside unit circle. What about zeros here? Zeros lies at 0, 0 and 2 by 3. Right? 1 0 at 0. 1 0 at 0. Okay. Another 0 at 2 by 3. 2 by 3 is nothing but 0.6. Maybe here. Oh, sorry. Right? So it is 2 by 3. So this is 0. Right? So all the poles and zeros must lie inside. But again here, one pole is lying outside. So it is not minimum phase also. So the given system is neither causal and stable nor minimum phase. So option, okay, where is the option? Option D, none of this. Right? So option D is the correct answer. I hope you understand the problem very well. If you are having any doubt, please ask me in comment section. Thank you.